Okay, so I've already turned on the web server on R3, and all we have to do now is configure our firewall, right? Our CBAC, or context-based access control firewall, in R1. So we'll open it up and we'll just do it right now. All right, so open that up. All right, here is the router. We'll say enable conf t to get to global config mode. We'll open this up here, and we'll start with our access list. So access dash list 100 permit 192.168.1.0 network, and then our wildcard bits to any destination, and we need to put our protocol before that. Okay, so I did an arrow over here, permit TCP and then a space. So that's what the line looks like. Access list 100 permit TCP from the source network, the one network, to any destination. Hit enter. All right, and then we'll just hit up arrow, and we're going to permit UDP from the one network to any destination. All right, and we're going to do an up arrow, and we're going to permit ICMP. All right, you can see that. Now, up arrow, and I'm going to delete this line here. And from any source to any destination, we are going to deny IP from any source to any destination. So we explicitly place a deny right there. All right, and that's the end of our access list, our extended access list 100. So all we have to do is now apply it to the interface. So we'll say interface FA0/1, and then IP access dash group, and the number of the ACL, which is 100, and then inbound. So that applies access list 100 to the fast Ethernet 0/1 interface. All right, now I'm going to do a Control C to get to privileged mode, then a conf T to get back to global config mode, and let's write our next ACL. So our next access list will be access dash list 101, and we're going to permit EIGRP routing protocol from any source to any destination. All right, and then we're going to also permit ICMP from any source, any destination, echo reply. Okay, and we're going to permit ICMP any source, any destination, the unreachable message, all right, and also the time exceeded message. All right, and then at the end we're going to once again deny IP all other traffic. So we're basically denying almost everything if you look at this. So with these statements, we're permitting the EIGRP routing protocol, we're permitting some ICMP messages to come through, but we're really actually denying everything. So if our CBAC, or if our control-based access control, or context-based access control rather, doesn't work, nothing will be allowed through. So let's apply this to the interface. So we'll say interface serial 0/0/0 and IP access dash group 101, the access list number 101, and then inbound. Okay, so now we've applied that. Now So what has that done? Well, right off the bat, everything should now almost be broken, except for we should be able to still ping. So if we go to our host A, right, host A, you can see that open up our command prompt, and we should be able to ping. And as you can see, we can ping, so that's great. But if we open up a web browser and try to get that web page from that web server, right, we'll go here and we'll say 10.2.2.1. That's the IP address of the other router that has the web server. You can see that I'm not getting a reply, right? Nothing. I'll hit refresh, and I'm not getting anything here, right? Right? Okay, that's not good. Let's make sure that our our ping worked, so we don't need to see if the EIGRP routing protocol is still working, because our ping still worked. And let's see if we can send that file. Now before, we were able to send it no problem. So we'll say dans.txt, and we'll see if we can put it. And you can see that this time when we hit put, we do not get a message. It says, oh, that didn't work. Internet Explorer didn't work. And our TFTP is not finishing, so we're not getting the successful message that we got before, right? It's kind of frozen, and we actually have to just break it if we want to get out of there. So it didn't quite work. Now once again, it's not that things are not being allowed out of the network, right? We have the permission statements on our access list, right, allowing stuff to leave the network. It's on the return that information is being blocked when it hits the firewall for coming inbound from outside the network into the router. So it's the return traffic that's being basically blocked because we haven't set up our inspection. We don't have our temporary ACLs being created dynamically, right? So our TFTP is not working. Now, something that is interesting about the TFTP is since this allows the message to get out, watch what happens if we try to do the dans2.txt file. So what we'll do is we'll just get it here. It's going to be allowed out, right? So we'll say dans2.txt, and we'll hit put, right? And you can see it kind of freezes here, right? But if we look on the other host, you can see that it actually received that message, because if you do a show directory here, you can see that it wants to have that file, dans2.txt. It's gotten the control message that it needs to create this text file, right? But if you go into Explorer and actually look at it, let's see here, view, refresh, there it is, and you open it up, there's no text in there. So the file didn't actually successfully transfer, and we never got the successful message over here. So the initial control message was allowed to go across on port 69, but with TFTP, it wants to open multiple channels. It wants to open multiple UDP channels negotiated at the application level, and those conversations are not allowed to cross the router, right? And traffic's not allowed back, so we have a problem here, and it's not finished. So I'm going to break that off, and we'll fix it now. So now let's see if we can fix it by putting in our inspection rules and creating our context-based access control, right? Okay, so we'll do a Control-C and a Conf-T to get to global config mode, and it's time to put in our commands. Let's take a quick peek at those commands again. We're going to put in, okay, IP inspect from global config mode, IP inspect, and then the name, and then our name, and what we're going to inspect, TCP and UDP, and then we're going to apply it to the interface. Okay, so IP inspect, name, CBAC -FW, so for our context-based access control -firewall, right? TCP, IP inspect, name, and then TCP. And then we're also going to inspect UDP traffic, right? And then we're going to apply this inspection rule to the interface. So we'll say interface FA0/1, enter. Now we're in the interface mode, and we'll say IP inspect, and then instead of name we just put in the name, and inbound. Alright, that's it. So now permits for TCP and UDP should work. So now let's take a look to see what we can do. So we'll go over to PCA, and let's see if we can get that web page now. So we'll go here to our web browser. We'll put in our IP address of our router and hit enter. And you can see that instantly we've connected. So the message came back, and now all we need to do is put in the password for the router, and we get our web page, our web interface from the router. There's the web server of the router, and we've been able to reach it. Now we can still ping, but now let's test out our TFTP server. Okay, for our TFTP server, we'll try to send that document again. So we've got the IP address of our remote host 3.100 port 69, local file dans2.txt, and we'll hit put. So we'll click put, and it says 1 block transferred in 0 seconds. So it looks like it was successful. And typically, now that didn't work for me before, right? I had a hard time with that. Let's go over and see if it truly was successful. We'll go over here, and we'll hit view, refresh, and it worked. So it actually worked on the UDP. Now, the first time I did this, it didn't actually work, and let's see if I can get it to not work. So I'll say new text file, and I'll show you that it's not very reliable. So I'll say dans3.txt, right? And then we'll type some text in here. I'm going to show you that there's a problem with it. Test number 3, all right. And file, save. And let's see if we can send that. So we'll hit over here, and we'll load in the third file here, and we'll say put. And it looks like it worked. So I'm surprised that it's working, but I'm not going to argue with it. But if you have problems getting it to work like I did the first time, what you can do is you can force the router to inspect at the application layer. And by doing that, what you can do is, or at least this is what I've read, you can put an additional line in here. So I'll take this, IP inspect name, and actually ask it to inspect TFTP, the TFTP protocol in particular. And I'm not sure if this exactly is true, but supposedly, and we could do some Wireshark captures to see exactly what's happening, or we can actually get some router debugging output to see what exactly is happening. But what we can do is we could say, well, if we want to inspect TFTP, maybe it'll go into the application layer and see the multiple UDP ports that TFTP opens up in a second session after the initial port 69 control information is exchanged, and it sets up other ports that it's actually going to transfer the files on. So all we'd have to do is add this line in, and to do that we would just go back in, and we'll just go back to global config mode, and I'll do an up arrow, IP inspect, let's see here, name, and you just add it in there, TFTP. Alright, and if you want to see if that worked or not, what you can do is do a show, let's see here, show IP inspect, and then put in the name, and show, alright, IP inspect name, CBAC-FW, and you can see here that TCP alert is on, UDP alert is on, audit trail is off. We'll be talking about those next time, and TFTP alert is on. So it's looking at all of those. So it seems as if the TCP and the UDP and the TFTP is now being inspected. If we do a show run to look at our running configuration, all you can see on our interface, you can see the inspection command that's creating the temporary permit statements from the outside on the serial interface. You can see that there's nothing there, just the access list applied to the interface that's blocking everything. And then there's our access list statements. So anyway, that's context-based access control.